The primary mirror on the Webb telescope will have a diameter of more than 21 feet. That's 4 times my height. Now that's too big to fit into a rocket, so engineers have had to design a structure that will not only hold all 18 segments of the primary mirror in place, but also fold up during launch. That's why we've come to ATK in Magna, Utah, where they're building the wings of the backplane.
There's 3 deliverables that ATK provides. There's a left-hand side wing, a right-hand side wing, and then a large center section portion. This design right here shows the wings in the deployed condition. When it's on top of the spacecraft prior to launch, they're folded back. There's 4 launch locks on the outboard corners of the wings.
Ooh, so what's a launch lock?
A launch lock is what is used to hold the wing in its tight packed position.
Oh, okay, so it keeps it in place during the launch.
That's right. And then once it's through the launch environment, the launch locks are released, and then the wings can be deployed into their final position.
So how far along are you in making these wings?
We're very far along, actually. You can go out and see the progress in the clean room with Ed Grahl. He'll take you on a little tour of the manufacturing facility and show you the wings.
Hey Ed, Brian just showed us the computer models of the backplane, but he said that the wings of the backplane are actually almost done.
That's really true. We've been working for quite a while on the wings, and we're very close to being able to have them completed. You can see them working on them here in the background. Each of these wings goes on either side of the center section of the support structure. Each of the wings holds 3 of the mirror segments, and then they will fold up during launch.
Any chance we can sneak in there?
Well, I would love to show you. Let's get our clean garb on.
Okay.
And we'll be able to go in and have a closer look.
Sounds good. All right, so what are these guys doing now?
They are bonding together different pieces that will make up the overall assembled structure. The thickness of the adhesive that they are currently injecting in at very specific points has to be held very precisely, because if there's too much adhesive, it'll want to pull itself apart at very cold temperatures. If there's too little adhesive, then it won't be able to withstand the forces of launch. Let's come to the far side. Now these wings, you can see first as you look at it that the wings are not flat. They have a curved shape, and that curved shape matches the parabolic shape of the overall mirror.
So each of the primary mirror segments would be facing down right now as opposed to being on top here.
That is correct. Let's come over this way. And you can see all along, as you're in closer, that we have additional shear panels that distribute and balance the loads that are experienced during launch.
Great. Well, thank you so much for showing us the wings of the backplane.
It's certainly my pleasure. Thank you for being here today.
As you can see, the backplane and its wings have to be very, very strong because the mirror segments collectively weigh about 3/4 of a ton. Thanks for joining us for this edition of Behind the Web.